Let us learn some more examples in the trigonometry, continuing our theta values. If sin theta is equal to 4 by 5 and theta is not in the first quadrant, find tan theta. Given sin theta is 4 by 5 and theta is not in the first quadrant. Therefore, theta should be in the second quadrant since sin is positive, because 4 by 5 is positive. Now cos theta is minus root over 1 minus sin square theta, which is 1 minus 4 by 5 whole square, which is root over 9 by 25 minus in the side is the sign outside, that is minus 3 by 5. Therefore tan theta is nothing but sin theta by cos theta, that is 4 by 5 by 3 by 5, which is minus 4 by 3. Now let us find another example. Find the value of sin 22 and a half. Solution: sin A is equal to root over 1 minus cos 2a by 2, that is sin 22 and a half is equal to 1 minus cos 45 by 2, because 2a is 2 into 22 and a half, which is 45. Therefore 1 minus cos 45 by 2, that is equal to 1 minus cos 45 is nothing but 1 by root 2 by 2. Therefore it is root 2 minus 1 by 2 root 2. Given sin theta is equal to 5 by 13, find the value of cos 2 theta. Cos 2 theta is nothing but 1 minus 2 sin square theta. Substituting the value of 5 by 13 in cos sin theta, we have 1 minus 2 by 13 whole square, which is 1 minus 51 minus 50 by 169. Therefore cos 2 theta is 119 by 169. Again another example, if cos theta plus sin theta is equal to root 2, find the value of cos of theta minus pi by 4. Given cos theta plus sin theta is root 2. This can be written as 1 by root 2, bring the root 2 here, 1 by root 2 into cos theta plus sin theta is equal to 1, 1 by root 2 cos theta plus 1 by root 2 sin theta is equal to 1, 1 by root 2 is nothing but cos 45, again 1 by root 2 here is nothing but sin 45, therefore cos theta is cos 45 plus sin theta is sin 45 is equal to 1, this is nothing but cos a minus b, that is cos of theta minus 45, which is 1, again 45 is nothing but pi by 4, therefore cos theta minus pi by 4 is equal to 1. So required solution for cos theta minus pi by 4 is 1. Let us see another example. If sin A is equal to 4 by 5, cos B is equal to minus 5 by 13 and neither A nor B is in the second quadrant, find the value in which A plus B lies. Solution: given that sin A is equal to 4 by 5 and A is not in the second quadrant, therefore A lies in the first quadrant because sin A is positive. Similarly, cos B is minus 5 by 13 and B is not in the second quadrant, therefore B lies in the third quadrant since cos A is negative. Now let us find sin of A plus B. Sin A plus B is sin A cos B plus cos A sin B. Substituting the value of sin A cos B and cos A sin B, 4 by 5 into minus 5 by 13 plus 3 by 5 into minus 12 by 13 is equal to minus 20 minus 36 by 65, which is minus 56 by 5. How did we get sin A? Sin A is 4 by 5, therefore cos A is nothing but root over 1 minus sin square A, which is 1 minus 4 by 5 whole square, which is 25 by 16 by 25 under root, which is 3 by 5. Similarly, cos B is minus 5 by 13, therefore sin B is minus 12 by 13. Now let us find cos of A plus B. Cos of A plus B is cos A cos B minus sin A sin B. Substituting the values, 3 by 5 into minus 5 by 13 minus 4 by 5 into minus 12 by 13 is minus 15 plus 48 by 65, which is plus 33 by 65. Therefore sin of A plus B is negative and cos of A plus B is positive, therefore A plus B should be lying in the fourth quadrant. Prove that cot pi by 16, cot 2 pi by 16, cot 3 pi by 16, etc. to cot 7 pi by 16 is equal to 1. Let us take the LHS. Cot pi by 16, cot 2 pi by 16, cot 3 pi by 16, etc. to the cot 7 pi by 16. Rearrange the terms in the following manner: cot pi by 16, cot 7 pi by 16, cot 2 pi by 16 into cot 6 pi by 16, cot 3 pi by 16 into cot 5 pi by 16 into cot 4 pi by 16. This can be written as cot pi by 16 into cot pi by 2 minus 6 pi by 16, cot 2 pi by 16 into cot pi by 2 minus 2 pi by 16, cot 3 pi by 16 into cot pi by 2 minus 3 pi by 16, and cot pi by 4. Now cot pi by 4. Now this is cot A cot A tan B, which is again cot pi by 16 is 1, tan pi by 16 is 1. Again this is also cot 2 pi by 16 is 1, tan 2 pi by 16 is also 1, cot 3 pi by 16 is 1, tan 3 pi by 16 is 1, and cot pi by 4 is nothing but cot 45, which is again 1. 1 into 1 into 1 into 1 is 1, required RHS. How did we get cot 7 pi by 16 as cot pi by 2 minus pi by 16? We can look at this. Cot pi by 2 minus pi by 16 is LCM, 8 pi minus pi is 7 pi by 16. Similarly, the rest of the thing, 2 pi by 16 into cot 2 and cot 6 pi by 16 was written as pi by 2 minus 2 pi by 16 in the same manner. Find the value of 2 sin to the power of 6 theta plus cos to the power of 6 theta minus 3 sin to the power of 4 theta plus cos to the power of 4 theta. Solution: left hand the required the given expression is 2 sin to the power of 6 theta plus cos to the power of 6 theta minus 3 into sin to the power of 4 theta plus cos to the power of 4 theta. Let us rewrite this as 2 into sin to the power of 6 is nothing but sin square theta whole cube plus cos square theta whole cube minus 3 into sin to the power of 4 theta is sin square theta whole square plus cos square theta whole square. This is nothing but a cube plus b cube. A cube plus b cube is nothing but a plus b whole cube minus 3ab into a plus b, and similarly this is a square plus b square. A square plus b square is nothing but a plus b whole square minus 2ab. Now let us rewrite this in the form of that two expressions. 2 into sin square theta plus cos square theta whole cube minus 3 sin square theta cos square theta into sin square theta plus cos square theta minus this is again 3 into sin square theta plus cos square theta whole square minus 2 sin square theta cos square theta. Sin square theta cos square theta is 1. Here also sin square theta cos square theta is 1. Here also it is 1. Therefore let us substitute 1 in those places. 2 into 1 minus 3 sin square theta cos square theta, and the second expression minus 3 into 1 minus 2 sin square theta cos square theta. Therefore multiplication with 2 minus 6 sin square theta cos square theta, multiplication with minus 3 minus into minus plus 6 sin square theta cos square theta, sin square theta 6 sin square theta and 6 sin square theta gets cancelled. 2 minus 3 is minus 1, which is the required value for the expression. Prove that cos 9 plus sin 9 by cos 9 minus sin 9 is equal to cot 36. Let us take the LHS. Cos 9 plus sin 9 by cos 9 minus sin 9. Now dividing the numerator and denominator by cos 9, we have 1 plus tan 9 by 1 minus tan 9. 1 is nothing but tan 45. Tan 45 plus tan 9 by tan 45 minus tan 9. Since tan of pi by 4 plus theta is 1 plus tan theta by 1 minus tan theta. So this is nothing but tan 45 plus 9. Tan 45 plus 9 is nothing but tan 54. Tan 54 can be written as tan 90 minus 36, which is cot 36, which is the required right hand side. If a is not an integral multiple of pi by 2, prove that tan a plus cot a is equal to 2 cosecant 2a and cot a minus tan a is equal to 2 cot 2a. Let us take the first LHS, tan a plus cot a. Tan a is sin a by cos a and cot a is cos a by sin a. That is, taking LCM, sin square a plus cos square a by sin a cos a. That is, sin square a plus cos square a is 1 by sin a cos a. Now multiply and divide it by 2 by 2 sin a cos a. 2 sin a cos a is nothing but sin 2a. Therefore, it is 2 by sin 2a. Therefore, 1 by sin 2a is nothing but cosecant 2a. Therefore, it is 2 cosecant 2a, which is the required right hand side. Let us take the second example. Cot a minus tan a is equal to 2 cot 2a. Let us take the LHS. Cot a minus tan a. cot A is nothing but 1 by tan A. Therefore 1 by tan A minus tan A, LCM tan A, 1 minus tan square A by tan A, 1 minus tan square A by tan A divided and multiply by 2, that is 2 into 1 minus tan square A by 2 tan A. 1 minus tan square A by 2 tan A is nothing but cot 2A. Therefore 2 cot 2A, which is required right hand side. Find the values of sin 75, cos 75, tan 75. Sin 75 can be written as sin of 45 plus 30, that is sin of A plus B, sin A cos B, cos A sin B, that is sin 45 cos 30 plus cos 45 sin 30. Substituting the value of sin 45 cos 30, cos 45 sin 30, we have 1 by root 2 into root 3 by 2 plus 1 by root 2 into half, that is root 3 plus 1 by 2 root 2. Similarly, cos 75 is cos of 45 plus 30, cos A plus B, cos A cos sin B minus sin A cos B, 1 by root 2 into root 3 by 2 minus 1 by root 3 into 1 by 2, which is root 3 minus 1 by 2 root 2. Tan 75 is nothing but sin 75 by cos 75, which is root 3 plus 1 by root 3 minus 1. We have learnt a number of examples in the trigonometry in the last few videos. This assignment will also give you explicitly how to solve the theta values as well as A plus B and C when given in a triangle, the values of A plus B plus C. And in the next few videos we shall learn some more examples to understand the subject of trigonometry in detail. In case you have any doubts, you can subscribe to my channel or look into my blog to find the solutions for these assignments.